think I have this working. I am hoping so. Um, yeah, so thanks for joining. Um, what we're going to cover off today is all about um, certificate validation. What does it mean? Uh, like, why is it important, and all of that good stuff. If you watched my stream last week on certificates, I kind of covered off certificate validation, but in this case, I'll kind of cover it off a bit more in detail. So, starting off with certificate validation, what is a certificate? Well, certificates are a form of identity. Um, they they're used in TLS connections, which is your secure connection. If you go to a site and you see HTTPS, that's behind the scenes. That's using TLS, the TLS protocol, to encrypt the connection. This is largely because HTTP didn't support it, so it's kind of like a bolt-on thing, but it works really well. I mean, this is how most of the internet's starting to run these days, which is good. Secure by default, have encryption, so not only protecting your privacy, but also protecting the data that's been transferred to you. Now, as you can imagine, if you're going to connect to someone, you could potentially connect to someone that you're not expecting to. This is often referred to as a man in the middle attack or a machine in the middle. So instead of connecting to, say, google.com, you're connecting to an attacker who's doing what's intercepting your traffic. So they'll sit between yourself and the server that you're trying to connect to. And then that way they can actually view any information that's traveling between you or modify that information. If you watched my stream last week, you would have actually seen this in practice. Hopefully, you would have seen this in practice with the live demo that I did with WebSuite. Now, just making sure everything's fine. Just want to make sure. So, I think everything is fine. So, yeah, connecting to a server, you need to make sure that it is in fact the server you're connecting to. So in this case, that's where certificates will come in. When a client connects to a server, part of the TLS handshake is the server will present to that client a certificate, and that indicates to the client the identity of the system that the client is then communicating with. The client will then do appropriate validation on that certificate to ensure that it is in fact the server that it's connecting to. And there's basically there's a bit more, but the three primarily main ones are that it validates that the host name matches the certificate. It validates the certificate is signed by a trusted authority, so a certificate authority. And then lastly, it makes sure that the certificate hasn't expired. There are other things like flags indicating what the certificate can and can't be used for, but those rarely would you have a problem with that. It's almost always going to be one of those three things that are an issue when it comes to certificate validation. Now, there's several tools that you can use to check a certificate. As I showed you last week, and I'll just cover it off again. So you can use OpenSSL. So S-Client, I can't remember how to auto-complete this. I'm a complete noob when it comes to Z-Shell. But you can use OpenSSL to actually retrieve the certificate, and then you can actually view this certificate itself. This is all great. And as part of the certificate validation, just recovering this, you making sure it's signed by a certificate authority that you trust. So in this case, you go look to the issuer. The issuer in this case is DigiCert. The client would then take the signature of the certificate, which is down here. It will take the public key, which is in the CA certificate that resides on your operating system. In this case, clients will have different trust stores. It could be in a browser, specific to the browser, but generally, or quite often, systems will use the operating level trust store. So think of it as a collection of all certificates belonging to certificate authorities that system then trusts. So it will take that public key, which belongs in the certificate itself. I'm trying to see if it's here. Yeah, so there we go. So every certificate has a public key, hence public-private key. Public key, share to your heart's desire. That's totally fine to be made public. The private key, on the other hand, needs to remain private. So when a certificate is signed, it is signed with the private key, and then you can use the public key to validate that signature. So it's saying, yes, this is signed. Whoever signed this certificate, I'll take their public key, compare it to the signature, and say, yes, this signature was signed with can only be signed with a private key that belongs to this public key. So in this case, we can say, for a high degree of certainty, that this certificate was issued by DigiCert. And this is why this is the most important step in certificate validation, because even if you do the other two, if you don't do this step, I could simply create the certificate to match the other two criteria. I can simply create a certificate to say it's for twitter.com. In fact, this is what happens if you go to something like Burp Suite. So let's go do that now. So if I'm going to change this to use Burp Suite, and we'll go off to Twitter, and you'll actually see the CA is different. So just start in Burp quickly. And this is going to be a very rudimentary kind of man in the middle or machine in the middle attack. This is what typically would happen. So the attacker would either use like a rogue Wi-Fi and get you to connect to that, or they could compromise a public Wi-Fi hotspot, say internet cafe, or they could do things like DNS poisoning, so forcing the traffic through them. A load of different ways. It's not trivial to do this, but it is possible. Okay, so we have Burp Suite running. So now if we go to twitter.com, should be trusted. But if we have a look at the certificate itself, you'll see it's verified by Portswigger. So it's actually in fact a different certificate. So you can see the issuer is Portswigger, and there's different information here. So you got, for instance, the modulus. So this public key should be different from the public key that's on the certificate, the actual legitimate original certificate. So yeah, you can see the public key is different, and more importantly, the signature will be different. And you should be able to see, where's the signature? Okay, it doesn't show the signature. But I could download this and verify. You just have to trust me that the signature is going to be different. Now, the reason why this doesn't throw up an error is because I have the Portswigger CA in my browser trust store. If I remove this and try to go visit the site, it wouldn't work because I don't trust the CA. And as I said, this is the most important step. If I don't do appropriate CA validation, I could simply create a certificate that matches the DNS name and the date and any other fields that I want to, and then I can do man in the middle. And this is also why you get to protect things like the private key, because if you get the private key, or if you're CA, you get the private key, then you can start issuing certificates to your heart content, anything you want to. But also with the certificate itself, if I get the private key, then I can use the certificate to spoof the server, which is why protecting the private key is absolutely vital. So, certificates in TLS connection are used for identity. Now, one of the other things you can have is a client certificate. So when you're doing the TLS handshake, the server will always have to provide its certificate. That's part of the TLS handshake. You won't have an instance where a client connects to a server and it doesn't get the certificate from the server itself. It needs to know it's connecting to the right entity. But the server can then also prompt the client itself for a certificate. The same principles apply. It needs to be signed by a valid CA that the server then trusts. The certificate needs to be validated. The only area that it kind of gets a bit iffy on is it's not as clear as the host name needs to match, because a client in this case is not necessarily a system. It could be a person. So myself, Sean Rutt, I have a certificate assigned to me. That's my identity, not my system that I'm running on. And this is where the validation around the CN gets a bit iffy. There's no, to my knowledge, there's no kind of standardized way of validating that, which kind of makes things a bit difficult, because sometimes systems will use the host name, otherwise they'll use the common name, which could be a person's name, and so on and so forth. But definitely from the server side, it's validating against the host name. And sometimes you can, I think, get it to work with an IP address. Certificates aren't just used for connecting to servers. They're also used for a variety of other things. So one of the other things they are used for is digital signatures. So if you want to sign a document, or another good example, sign an email, you can use a certificate to do that. So similarly, like how CA will generate a certificate, sign it with a private key, and then you validate it with a public key, you can do the same with signing data. So you would sign it with a private key, send the signature with that data, and then the client or the receiving end can take that signature, check it against a public key, and make sure it's been signed with that private key. What else can certificates be used for? Yeah, that's primarily it. I think there are other cases, but those are the most common cases of using a certificate. Cool. So, just checking if you got any questions in that, just please drop them in the chat. Now, as I mentioned, validation is important, because if you don't validate, then you may as well not use TLS connections. Anyone can then simply do a man in the middle or machine in the middle. And it's often quite difficult. So there are tools out there that allow you to test. So I did mention in the last week, Qualys has quite a good tool called SSL server test. So you can go off and it will test for things like, is a certificate correct? There are also local tools such as test.ssl.sh. And I forgot the command last week to do what I was wanting to, but I remembered there's a tool, really cool tool called AHA, and allows you to pipe, or basically take console output and generate HTML. So if you run this, you can kind of create a nice little HTML report for your local tool. So test SSL or SSL scan or SSL LAS, you just pipe it to AHA and then redirect that to HTML file, and then it'll generate like a pseudo report that you can then store and share, and it just makes it pretty nifty. Or, as I mentioned, you can use a tool like SSL, Qualys SSL server tester thingy, or there's a MuniWeb. With this, you could just print the page to PDF. MuniWeb allows you to download it. Now, while that's running still, you may be wondering, okay, how do I test that? Say, for instance, I'm building an app, and how do I test that this app is doing the right validation? It connects to a API or something, and I want to make sure it's doing the right validation. Well, there's an awesome site called Bad SSL. I think it's badssl.com. I think I forgot who this. I'm pretty sure it's Firefox, and I think Google as well run this. Now, you can, as you see, it's on GitHub. Now, the cool thing about this is you can actually run this yourself. So if you have internal CAs, you can actually spin this up and use those internal CAs to then test your own internal infrastructure, or you just point to the public one you have. And we'll go through each kind of one of these and can have a look at those different issues there. But yeah, I highly recommend you go have a look at this. Yeah, you can run as a Docker instance, all sorts of things. It's a really, really great tool. Yeah, so both Google folk as well as Mozilla Firefox. Really, 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 really powerful tool when it comes to testing your TLS verification or certificate validation. Hopefully, that's not done yet. Hopefully, it'll be done soon. Before I start that, all right, well, we'll come back to that. So, dashboard, I think this just gives you kind of information about your client and how it validates certificates. So in this case, why did I connect? Okay. This probably didn't work because I'm going through Burp, which is in itself then creating a certificate and connecting. Burp Suite itself would probably connect. So this is kind of a case like, this is bad. These would be bad examples of a poor certificate validation. Like the certificate's expired. It's not good, but it's certainly not as bad as something like an untrusted root or a wrong host. And then there's the other validation done there. So we'll run this again without me going through Burp, and it should all work properly. I just want to make sure this is finished. No, it's still going. Yikes. So let's go directly. Refresh this page. I don't know why it's going so slowly. Yikes. Did I break it? There's something up with my connection. Hope not. Yeah. Close Burp. While I'm here, in Burp itself, you can actually also go see all the certificates that it's basically created. Where is it? I think it's in project options, TLS. There we go. So you can actually see all the certificates that it picked up on, and then it went off and created other certificates as well. You can also go into the proxy and do a TLS pass-through. So what this means is Burp won't actually intercept the requests. It will just send it straight through to the server. And then that way you'll get all the connection problems. I just want to check my connection, yeah. Let's go to Google. Okay. All right. Well, hopefully this will work. It looks like there's a problem with bad SSL. Talk about timing. Just want to make sure the site's actually still working. Well, that kind of sucks. just want to make sure that it's not cached or anything. No. Would have to pick it at this time. Let me try do one thing. Let me try close the browser, clear my cache, and all of that good stuff. In the meantime, since that's finished, here's the output of that AHA file. It's pretty awesome. It's not going to be the world's best report, but it does the job pretty well. So as you can see all the stuff here, and you can also see stuff about the certificate is down towards the bottom. There we go. There's all the stuff about the certificate. So this is good if you want to like have a report that you could give someone, or you want to like, I don't know, document it and all that good stuff. So you can do that trick. So let me just kill that. Oh, it might have been because of that was open. Anyway, let me double check and clear cache everything. Yeah. Right. Bad SSL.com. Bad SSL is not working. Damn. Just want to check on another system. Oh, there we go. Yay. Maybe they had some sort of issue. So a good way is testing this out. Just go using the browser. You can see all the issues in the browser. So in this case, we want to see, okay, well, certificate expired. So if we actually go and view the certificate, well, it expired some time ago, 2015. So what, almost 7 years ago? No, yeah, almost. What's the date? Oh, just short of 7 years ago. So there's that. So if you're using something like curl, so what we can do is that, and that. So -v is just for both, and there we go. You can see it's like failed because it's SSL connection. Now, what you don't want to do is this. You might see this in some scripts. This is bad. So -k is just ignore certificate validation. So you can see there it went through. That is bad. I forgot what the full command is. It's like no search check or something like that. wget is the same. There's a -- no certificate verification or some option like that. If you check the manual, you'll be able to find it. Those are bad because they disable certificate validation, which is bad. Certificate validation, in my opinion, is like one of the most important parts of a TLS protocol. So that there is expired, wrong host. So in this case, let's go have a look. So we got wronghost.host.badssl.com. What does the certificate look like? Let's go information, view certificate. So this was for star.badssl.com. Now, star.badssl.com is what's called a wildcard certificate. So the star means anything.badssl.com. So you might go, okay, well, this is wrong.host.badssl.com. So that's anything.badssl.com, right? Well, wildcard certs only work for subdomains. So in this case, it would only work for example, host.badssl.com. Or if the certificate was star.host.badssl.com, then that would work. So it only works one level. And there's a whole raft of other reasons, like I don't like wildcard certs, but we'll leave that for another point. There's a blog on my blog post that kind of one of the first posts that I wrote, where I go into details like why I think they're not always the best thing. Just got to be careful. Now, self-signed cert. So if you go look at this, what you'll see is the issuer and the subject are going to be the same. As the name suggests, you've signed this yourself. So you've kind of created it yourself. If you're ever spinning up kind of default servers, you'll probably find this happens a lot. So they almost always come out like generate their own certificate, which is self-signed, or they might just come out of the bat with the self-signed certificate. You generally want to be careful about these because, again, you don't know who has had access to this or how this was generated. Not saying they're always bad, but if you can, avoid trusting them. So that's self-signed. So now here's where we're getting on to CA validation. And if we now go view the certificate. So what we have here is this bad SSL, untrusted root certificate authority, and we don't trust the CA. Now, what I could do, let me actually do this, is if I download the certificate, let me save it there, and I'll come to the settings. In Firefox, it's under privacy and security, and then you kind of go right to the bottom, you go view certificates, and we're now going to import this as a trusted CA. I'm just going to remember to remove this. Okay. And if we now do that, okay, well, that's like a big bad thing. So if you're getting this, you're not doing appropriate certificate validation, or you've explicitly trusted that CA. And you can see this by the lock at the top. It's not showing any errors. Whereas if I now go and remove this, let me go remove this. It was what? Bad. Oh, that one. So you can go delete this trust and okay. If I come back here, it should now. Oh. I might need to clear my cache. Let me clear everything. There we go. And you can see it's back to that connection error. So that's why you're going to just be careful with anything that you import. Make sure that you can trust that whoever owns that certificate, so they're doing the right things. Without getting into nitty gritty, you have, so there's a CAB forum. There's a whole bunch of processes around third-party CAs. So different things like they have to submit to the certificate transparency logs, which I covered a bit last week. Then there's a whole host of controls that they need to have for how they protect their private keys and how they generate certs and all of that. So that's why it's fine to trust those, but generally any other ones, you want to be a bit wary. If you're a company and you want to have your own certificates or even in your own local network, as long as you've got full control over that, you should be good. So we did that one. Revoked. This one may or may not work. Okay, that's surprising. This has worked. Sometimes it's not going to work. I think let's try Chromium. Do I not have Chrome on here? Okay, I don't have Chromium. So sometimes it may or may not work. It all depends on the client. So the client may not actually do certificate of revocation checks. If I think we go here, let's see if it actually. Okay, didn't even get the certificate, which is interesting. But yeah, sometimes the client may not even do this check, and you'll see it actually go through. Now, pinning is old, kind of an older way. I think Firefox still does it, as you can see here, but I think Chrome no longer does this. Let me see if I can actually install Chrome quickly. Now, padding is actually explicitly not that explicitly tying a certificate with the actual request, or sorry, response from the server. So you will then, rather than doing your typical certificate validation, so CA, all that, you actually check that the certificate that you're getting is the same certificate that's actually part of that response. So hence the pinning. So you're actually tying it to a specific certificate. Now, this is the most secure option, because if the CA gets compromised, that kind of thing, it then means that it doesn't matter, because that any new certificate that's going to get created is going to be different from the one that you actually pin into. On the other hand, it does cause problems, and it makes a bit of a nightmare when it comes to management, because you could potentially end up causing problems where if the certificate expires for some reason, then you can't just simply go and quickly update it. There's caching and all of that. And pinning's probably more common on mobile apps. And this is even more of a problem in mobile app, because if that certificate then expires, you essentially have to or issue a new version of that mobile app. I know some people do prefer it. Personally, I don't like it. I think it's got too many kind of downsides to it, if that makes sense. And it's just an additional burden and overhead for not much value. As long as you're doing correct certificate management, the chances of that certificate being compromised is pretty small. And the overhead of doing certificate pinning is just, pretty significant. So I'm gonna hope it's gonna work, but let's try it out. Hopefully this will work. So it was with the two sites, pinning and revoked. Cool. So Chrome's now installed. So let's copy this link. I know in the old versions of IE, you used to be able to actually disable and enable certificate revocation checks. Right, so let's go. Okay, so Chrome still does certificate revocation checks. So this used to be in a header. Let me see if I can actually get the request as well, so we can see the header. Let's go network. Away we go. Okay, maybe I was wrong. I know they were looking to deprecate it. Headers. Where's the response? Okay, that's weird. I need to double check this. So you can actually see it's sent off the request header, but it's actually not going to response back. I need to have a look at this, but if you go look, there's a security header called HSKS or something. HSKS. I think this was the pinning. Oh, Connor. No. Or was it HKP? P something. There we go. That's the one I was looking for. So yeah, here's a header that you can actually set. As you can see, it's deprecated. And this is what you used to use on sites to do certificate pinning. So that's pretty interesting. I don't know how they're doing the pinning, which is pretty interesting. Right, so let's go to the next one. So no common name. So if we go look at the certificate, we should see, so there's no common name. So it's only got all of that. And one thing I want to see is, does it have the subject alternative name? So in the past with certificates, you used to only really get a single host for the cheapest type certificates, and that got set in the common name. So common name equals host name. And browsers used to use that as a means of validating. There's this other field called subject alternate name. And this can have numerous entries, so multiple entries within here. So DNS is one. You can even have like email and that kind of thing. And the idea behind this is you can use one certificate for multiple servers. So you could have no common name, .badssl.com, test.badssl.com, and so on and so forth. And then you can use the same certificate for all those servers to find in here. You can even have a wildcard with host names if you so desire. Technically, according to the RFC, as far as I know, this is okay, I think. This is where it gets a bit iffy, and you'll see like different interpretations of RFC spec. Now, Google Chrome will not approve. That sticks pretty closely with the RFC. So the way it works is it's going to check the SAN, so subject alternate name, see if there's a DNS entry in there. It will then use that DNS entry to match to the server. If that doesn't match, then it will reject the connection, invalid hostname. If there is no SAN, then it will look to the common name. I think it actually does even look to the common name with Chrome. So if we try this is going to be interesting if this is going to work in Chrome. So let's go try it in Chrome. Okay. Okay, so that's got no, so if you see here, it actually went past that and it got no certain valid. So what was the certificate dates? Certificate's expired. So it's probably working because it's got the SAN, but the certificate has actually expired. No subject. And this is the problem, like different clients validate certificates in subtle ways, so you can get variations. So in this case, this one failed. Will it fail in Chrome? Well, the date's not valid, but as you can see, there's no subject. Just issued by, and there's no subject, which is interesting. And then this one here is a incomplete chain. Now, if you attended last week, that's interesting. If you attended last week, certificates can change. So you typically have a top level signing certificate, root CA, and that can create another certificate underneath it, which can also be a CA, and so on and so forth. There's no limit as to how many you can have. And the way it works is if you trust that root CA, you can then trust everything that it signs and everything else that it, like what's termed subordinate CAs, signs. So root CA, subordinate CA, and so on and so forth. And as long as you can chain that back up to the root CA and you trust the root CA or some level up, you can trust that certificate. So say, for instance, you had like 5 levels. You wouldn't really have that, but it's technically possible. You could go up to level 3 and just trust that certificate. And as long as you have the certificates presented by the server, what's known as a certificate chain, up to that level, you can then trust that certificate, because you can work out that certificate signed the next certificate, that signed the next certificate, that signed the service certificate. If that full chain's not provided, you can't work your way up. So you're going to go, okay, well, this signed that certificate, and that certificate was signed by that, but who signed this? I don't trust that, so therefore not. Which is why I'm pretty interested about this, because this here is signed by DigiCert. So we must have this in our trust stores somewhere. So what we can do is actually go look at the common name. So DigiCert SHA-2. So if we come back here and we go to certificates here and we look for DigiCert. What was it? DigiCert SHA-2. Okay. So we already have this in our trust store. Now, if I remove this, this wouldn't then work. And what you can also do is view this. This is now signed by another cert, which is the DigiCert Global Root CA. And I think we have that. Yeah, we have that there. So the point of this was, this certificate here is assuming that you don't actually have this DigiCert SHA-2 in your trust store, and if you didn't have that, then it wouldn't work. So what we could do, go to our trustee Qualys. Should make it a bit easier to see. I'll take a bit to scan it. All right, let's go. Hopefully that's going. All right. The other ones here, I'm not going to go through all of these, because these are now getting more towards not really certificate validation, but now part of the protocol handshakes. Actually, no, I lie. These are part of the certificate. So the SHA is the signature. SHA-1 or SHA-1 to 28, or just SHA, is bad. It's hard to exploit. I don't know if there's any known public exploits of this, but there's known weaknesses with SHA. So SHA 256 and above is now what's recommended. And I think browsers don't trust SHA certificates anymore. I could be wrong, but I certainly know in terms of when I was mentioning the CAB forum, CAs aren't allowed to issue certificates signed by just SHA. It has to be SHA 2 or 256, same thing, and above. These other ones are also part of the public-private key. Wow, we're going up to 8,192. Not seen that before. That's pretty big number for a private key. So these here are defining the size of the private key. So 2,048 bits, 4,096 bits, and so on and so forth. This is an elliptic curve. Ephemeral elliptic. I always get the ECC mixed up. And then this is RSA. So Randall should be you can go look it up. They two different private public key algorithms. Extended validation certificates. This is a bit of a controversial subject. Now, one of the things that are around certificates are ordinary certificates. Anyone can go request them. As long as you can prove that you own that domain, you can go off and request that certificate. Now, that domain may mean you're not a legitimate person. So you could try spoof an existing domain like Google. Now, I've tried this, got so far, and it quickly got taken down. So they are kind of on the ball, but you can still play on words and that kind of thing. Or you can just create an totally separate new domain and try to get people to use it and make it sound somewhat legitimate. Extended validation is kind of put forward by certificate authorities as an extra step. I kind of guess where they're going with this, but in reality, it's not always the case. Extended validation means you need to provide extra identity. So you need to do things like prove your address and set up, like prove your company and all of this other stuff. So actually, domain validation is the normal way of doing it. So that's where you prove you own the domain. So that's all done automatically, technical controls and all of that. Whereas extended validation, or EV, is where there's often a human doing the extra validation, extended validation. Reality is it doesn't really provide that much additional value. And that's why it's a bit controversial. Some, the CAs, say it does, where in reality, maybe it doesn't. Before, in the browsers, it used to like show the host name and all of that kind of stuff. Started going away. So to ordinary users, external validation is becoming less and less obvious. And that's why probably a lot of the value in getting something like that, which you do pay more for this, is falling away. And I think they're becoming less and less of a thing. The other thing is, if you go look to certificate automation, so it's one of the most common things around certificates in organizations and outages are expired certificates. And that's a pain. They just expire. Like in the past, it was 2 years. Now it's a year in terms of maximum length that a certificate can be valid for. Well, it's actually, I think, 13 months. So you get 1 month grace period. And I think that's going to go down further as time goes on. And these are dictated again by the CAB forum. And that means we're getting to a point where we need to have some automation in place. And one of the great certificates out there is Let's Encrypt. This has kind of been a real game changer in terms of certificates. It's really changed the whole way we approach certificates. Let's Encrypt is built off what it calls ACME protocol, so automatic certificate management. I forgot the acronyms. I'm horrible with acronyms, but it's a protocol for automatically managing certificates. And the beauty of it is everything can be done programmatically, from the request to installing it. And that means when it comes to renewal, it can be all automated. So much so that certificates for Let's Encrypt are only valid for 90 days. And you basically fire it off once using a tool such as CertBot, which will set up a nice cron job, and it will go off and do its magic, and you never have to worry about that certificate again. It will just continuously renew itself close enough to the expiration time. And then you can even it'll even email you when there's any issues, automatically updating that certificate. So that is a fantastic approach. And that's kind of the reasons why I think we've now really seen a massive ramp up in terms of adoption of HTTPS, is because of the whole protocol. It's changed the way things are. You got things like installers now bundling in Let's Encrypt within the installation process, where you just simply put the domain in, forgo, get the certificate, pull it down, set up the cron jobs. You never have to worry about certificates. So it also abstracts the whole complexity around requesting certificates and then getting them issued and installing them. Does that all for you. So that's extended validation, domain validation. There's also organizational validation that kind of validates the organization that owns that certificate. OV, not that common. EV is the next, and then DV is by far the most common certificate. Now, this is where I was talking about client certificate validation. So in this case, this is right. So we've made it past the TLS connection or the handshake. So the client certificate validation is done as part of the TLS handshake. So when I connect to the server go, here's my certificate. Can you present me your certificate? And in this case, I don't have a certificate to present. So therefore, it just goes, no client certificate was sent. Now with client certificates, there are kind of three ways you can make it. You can make no client certificate required. So that's like vast majority. Optional. So the connection will still happen if I don't provide a certificate. So this is good typically with like authentication, where client certificate validation may be one option to authenticate to a server. So if they don't present the client certificate validation, then you go, okay, well now enter in your username and password. And then the last one is it's required. So if you don't provide a client certificate, then the TLS protocol, TLS handshake will break and you won't connect. So that's the next one in this step here. So this one here should now break, which it didn't. That's weird. Okay. That is okay. Don't know why that didn't work, but it should have broken. Again, don't think it's going to be the client itself, but we'll try. Because the server is now the one doing the validation. Okay, that's not what I was expecting. So the server is one doing the validation against the certificate, and it should go, no, don't, you're not presenting a client certificate. I expected one, so I'm going to break the connection. If using something like Apache, you'll see there's different options like optional and required. Mixed script. Now, this here should have provided a error up here. Let's see, Chrome. Oh, not that one. Okay, that's strange. Now, what mixed script means is, imagine you load in a page, right? And in a page, you load it over HTTPS. Great, everything is fine. But that page also has its own resources. So you're talking about things like images or style sheets, so CSS or even JavaScript files. And those are then loaded over HTTP. So now you have a mixture of HTTPS as well as HTTP. So let's go view this. Okay. That should have given an error at the top. I'll need to investigate that. I know this is where the browser made a change where they would like warn you at the top that you are now loading this. Have what's termed mixed script. So you're loading the site over HTTPS, but you have some content within the site that is now loading over HTTP. And this is insecure because someone could then do a man in the middle and actually modify the script. And then think about JavaScript, kind of like client-side remote code execution. So they could redirect you to sites, use it to try pull things. I'll do a demo sometime of Beef, browser exploitation framework. That's like really a really interesting tool where you just need JavaScript core to do what's called a hook, and then you basically have command and control over the user's browser. So that's why like things are mixed scripts are bad, because then you could do things like that. But it should provide an error here. I don't know why. That's strange. Is there anything on the console? So yeah, you can see mixed script or mixed content. It's there, but it normally there's an error at the top there. Don't know why it's not showing there. Anyway, cool. Very, maybe this is. So there we go. Now we can see there's an error there. So in the previous case, it was just a JavaScript file. And if we go look at Chrome, let's do that. Oh, Chrome still doesn't show that. So in this case, if we go so we still got that script, but then we also now have this image as well. And you also have what is a form, which should be down here, that is doing a post to HTTP, which is bad. So if you imagine like this is a login page, you're loading the page over HTTPS, great. But then you're doing a post, say login over HTTP, that way an attacker could steal your credentials. And then, yeah, there's varying bits here as well. So in this case, like mixed form, kind of another bit on that of the other one. So it's just plain HTTP where you submit it over HTTP. I'm pretty sure they used to give an error. Anyway, then maybe they're a bit more, yeah. So they're a bit more wary of the errors they're giving you. So in this case, this will be a login form, and if we inspect it, so we logging in over HTTPS, I think. No, we're not. No, it's not. This is just over plain HTTP, which is bad, right? It's same as these. These are all HTTP only. And then other ones, yeah, like these are Cypher suites. So these are after the certificate validation. So certificate validation happens first, and then agrees on the Cypher suite to use, and that's where all the magical encryption happens. Coming back up here, so these key exchange, that's again after certificate validation. So certificate's been validated, approved, then both the client and server would decide on a key to use for the encryption. Protocol happens before the certificate validation. So this is where the client and server will agree on the protocol they're going to use to communicate. This is important because this defines things like what Cypher suites they can and can't use, what supported key exchanges, and all that stuff. This one here is interesting. So Firefox doesn't validate. So as part of certificates, third-party CAs, they have to publish to the certificate transparency logs. And if you go to a tool like cert.sh, this looks up in certificate transparency logs. So if I look for myself, you can see all the certificates that have been issued for my own domain when that decides to finally load. While that's loading, let's go to here. Okay, so, and again, this is why there's difference between the different browsers and all of that. So Google, it's not surprising, with Chrome, Google are the ones who came up with the certificate transparency. What happened is, I forgot when, last in the 2010s or something like that, Google started noticing certificates for domains that it owned, but it never requested those certificates. So somehow CAA was misissuing certificates for a Google-owned domain, and that's obviously very bad because that could be used for bad purposes. So Google came up with this protocol feature, whatever you want to call it, certificate transparency. And it means whenever CA issues a certificate, they have to publish this information to these certificate transparency logs. I think there's 3 of them, so if one goes down, it doesn't get lost and all that good stuff. And it has to be public, so anyone can look up a domain and see what certificates are issued for it. And this is cool because there are different services out there, like Cloudflare offers this, where you can put in your domain or domain you just want to monitor, and you can actually see every single certificate that's been issued by a third party for that domain. So in this case here, you can use tools like this as well, and you can see all the certificates issued for that domain. It does have the downside that if you are issuing certificates for internal servers and you're using a public CA, those internal servers will then be exposed. This is probably one of the rare occasions where I have to admit that wildcard certs can help with that, because it's star, so you could use it for anything in your internal domain. Another option is to roll out your own CAs, but there's extra burden and all of that with that. And then the other one is you just accept that your internal domain names will be made public. So that's CT. So it is interesting that Firefox is okay with that. Let's get this. Let's get rid of all of these. So yeah, Firefox is okay with that, but Google's not. Yeah, this is the problem. Like, clients validate things differently. HSTS. Now, this is a really important security header to set. So this is HTTP strict transport security, I think. I'm bad with acronyms. What this header does is it defines that the site must always be loaded over HTTPS. So regardless if the user enters HTTP, it will always go over HTTPS. And we can test this out. So if I put this here, what we're going to do, I'm just going to clear my cache just to prove it. And what we are going to, in fact, no, I can't do that. So let's go to the network tab. So we've got HTTPS there. If I take that away and make that a HTTP, now what you would expect is this to go straight to HTTP, then a redirect to HTTPS. That's normally the way it works without this header. You would do either permanent or temporary redirect. Probably want to do a permanent, so next time the user tries to go to HTTP, they will automatically be redirected to HTTPS. But using this magic header, you will straight away be sent to HTTPS. So in this case, here we can see, if we go here, did that not work? Wow, okay, I am not winning tonight. So it did that. There's a few bugs in this tool, unfortunately, by the looks of it. Now, what I would expect is to go straight to HTTPS, or at least a HSTS header being sent back in the response, and it didn't. Not to worry. What we'll do is go to my site. Now, my site does have this blog. And if we view the network tab, let's see. Right. So you all saw that I entered HTTP. Let me just double check again, just to make sure, because I want to make absolutely sure I did that. Yeah, I did. And you can see the request was actually made to HTTPS. The browser knows that the site must always be accessed over HTTPS. And that's done by this security. There we go. Strict transport security, HSTS. And this defines to the browser that the site must always be loaded over HTTPS. Now, there's an additional flag on this called preload. Now, you can imagine, I've never visited the site. It's the very first time I'm visiting the site, which was what I was expecting here. I load the page over HTTP, and I still got to get that header. So the very first time I'm going to hit that site or clear my cache, I'm going to hit the HTTP. Now, the risk is very, very small, but it'll still be nice if you could just force your browser to do that automatically. And this is where this preload goes. So there's a preload flag that you can set, and there's a preload, I think, check that you can also do. And this kind of forces it into the list. So yeah, there's a submission list. So what you can do is actually put your site in here, blog dot, and off we'll go and check. And this will actually put it in for submission to be baked into the browser itself, HSTS. So regardless if the users ever visit your site or not, again, I can prove this. If I just clear all the cache and I try hit this again over HTTP, let's clear that. It will always serve this over HTTPS, regardless of the state of the browser, because it is preloaded, baked into the browser. And that's a pretty cool feature. Top tip. This is where the developers are probably going to shout at me and moan at me. What you can also do is have this include subdomains. So this means for the domain sean.wright.com, or subdomains of that will always be served up over HTTPS. And you can't bypass that. So if you want to force your systems to be always served over HTTPS, set that security header, preload it, and no other sites will be able to be served over HTTP. Everything has to be served over HTTPS. Also, the other thing with this is when this is in play and you have a certificate error, which I think I can try do now. Yeah, let's try do this. So typically you might have a certificate error where you can just, click through, accept this certificates. With HSTS set, you can't do that. I'm going to the wrong side. Settings. Come on. I've not used Google Chrome for so long. Privacy and security. As a network, where do I set? I'll just do it in Firefox. So what I'm going to do is certificate. I'm just going to remove the burp certificate and then go visit my site. Where's port swigger? There we go. So if we delete this, enable. Oh, why is it doing that? Let's close that again. So if we go there and we go to, say, Twitter, I don't think this has HSTA. So that's interesting. Why is it? Don't know why that's not working. Okay. Oh. Would help if I actually had burp running. Interesting that this is cached. Ah, got offline webs. Okay, so if we go now, okay, so there's an error, and I should be able to certificate. No, okay. Okay, so that's what I'm going to show. So this has got HSTS enabled, and you can't actually click through. If you want to go to site, I'm probably going to battle to find one that doesn't have HSTS. I'm going to try different ones. Okay. So, cool. This is one that doesn't have it. So this has got HSTS set, and as you see, this is the end of the game. I can't proceed any further. Without that enabled, you can go accept risk and continue. So this just, again, from a user point of view, it kind of like further enhances user security, so they can't actually click through and go any further forward. Again, if you go to my site, I can view the certificate, but that's it. I can't actually click through. Whereas something like this, it's not got HSTS, and I can actually click through and still navigate to the site. So if you got like any login pages or anything like that, and the user clicks through, they're going to be vulnerable. So that. All right. Let's actually see if that SSL has it. It doesn't have HSTS, which is interesting. So if we can click on this, what will this do? It doesn't have HSTS. So I can actually go through and preloaded. So that is that preloaded. Okay, so this does have HSTS enabled, and yeah, all good. So HTTPS Everywhere was a plugin that was used. I think it's now been deprecated. So you didn't have, back in the day, you didn't have the HSTS header. So we still had sites, and especially like behind the scenes, being served over HTTP when they could support HTTPS. So it would attempt to do HTTPS first. If that failed, then it would revert to HTTP. So things like HSTS headers and that have gone a long way. Yeah, and then there's other things. So these ones here are CAs that have been compromised. So they are ones that you don't want to have any sort of trust. So let's switch back to that. If we come back to this one here. Right. Don't know what's going on with that. Let's try it in Chrome. Okay, there's something wrong with that. But yeah, you can try those. And then, yeah, there's different other ones there. So that's certificate validation. Highly encourage you to make use of this tool. There are some caveats, and that probably got to go look at them and investigate it further while some of those things worked or didn't work. Maybe there's some bugs in the tool or something like that. I don't know. But hopefully that's been useful. And yeah, remember, certificate validation is really, really, really important. So if you see those things on like Stack Overflow where people have certificate errors, and then someone pops up and goes, yeah, just do this, where it removes certificate validation, don't do that. Unless it's really not important. So you're talking like internal development environments and that. Don't do that. It's risky. Rather try get the certificate working and fixed. That's far more a much better approach. Hopefully this has been helpful and useful for everyone. I don't know what I'm going to be on to next, but hopefully it'll be something exciting, and hope to see you all then. Have a good one, all.
Swear I won't forget this, why do I regret this? In my mind reckless, thoughts are feeling endless. Sitting up I'm breathless, anxiety's infectious. I feel so defenseless, betrayed and embarrassed. I hate being open, I hate being broken. I feel like an ocean filled up with emotion. Anger ain't a potion, rub it on like lotion. I can feel it soaking, reopen, the scars have awoken. I can't move on till I let go. I feel so lost, never at home. Need to be strong, every breath hold. Cause I can't move on till I let go. I can't move on till I let go. I feel so lost, never at home. Need to be strong, every breath hold. Cause I can't move on till I let go.